I want to shoot a quick video, a little POC that I built to try out a couple things with AI. So I'll just demo the app first, then I'll talk about why I built it. But what this is, it's a character buff generator. And the idea is that you can use AI to dynamically create new buffs for your game. So we could say something like, we could just use prompting. So a druid buff that gives the user enhanced intelligence, like seriously a lot of intelligence. So hit send. And what that's going to do is it sends it off to the backend. The backend is doing some work through queues. I'll explain that in a second. Uses AI to give it a name and a description. And then the stat change. So here, plus 10. And then we're going out to another AI service to get the image back. So why did I build this? Well, I built this because I'm super fascinated by this idea of what I think eventually will be AI-powered, procedurally generated endless games. And so the idea behind that is that game designers would set the rules of the world. So things like, is it a side-scrolling platformer like Mario? Is it a top-down adventure like Zelda? That sort of thing. But we can use AI to essentially to create new elements of the game. So buffs, items, enemies, dungeons, etc. My thought process is like, how much can we use AI to essentially steer and direct the world? And we program the rules, but AI can kind of take it in whatever direction. So that's kind of the exploratory idea. The other thing that I want to touch on too is that I don't remember, it was sometime this year where OpenAI in their API, they started allowing for structured outputs. And this is a big deal to me because back when I created Heizu, and I don't know if any of you all remember that, but essentially it was a Raspberry Pi device that you could press a button, talk into a microphone, and that was the Raspberry Pi app that would talk to a backend server. The backend server would go out to Whisper, to take the audio file and get the text out of it. Then it'd go to, OpenAI to get an LLM style response, and then it sent it off to 11 Labs, and eventually ended back up at the Raspberry Pi device. And the idea was that patrons at the zoo could ask and exhibit questions and get, with words, and then get words back. But back when I built that, all the APIs essentially string in, string out. And what I couldn't do back then, I tried to do it, but it was kind of, just didn't work that well, was we tried to shoehorn some of these string responses, and you try to write logic to kind of squash it into a JSON object, and it didn't really do the thing. That was 2 years ago. But when OpenAI released the structured outputs thing, I was like, oh, that's neat. This is going to be really cool. And so I've done a lot of little experiments, and this I'd probably say is not the biggest one that I've done, but this app uses that idea. And so I'll write about a lot of this stuff, like the endless game concept and structured outputs, and probably do a full write-up on this particular app over here on the After Camp blog. But I want to shoot this video and kind of just walk through a little bit of how this thing works. So what I want to show you here is just, I use some agents, and then I use those structured responses, those structured outputs to create the text. So the name of the buff, the description, and then the stat change. So over here in the code, forgive me a little bit here if it's a little messy. I was just like, hey, I'm going to just write this quick. So here's the way it works. So if you haven't looked at the agentic API for OpenAI, gosh, that's a lot of words. If you haven't looked at that yet, this might look a little bit foreign to you, but essentially what we're looking at is OpenAI's agents. And so here we just have a simple agent. I might do more with this later. You could just build a service that does this, but I might daisy chain and add in some stuff that might make agents a little bit better later. Anyways. So here we have essentially, we built the agent, and the agent's talking to the API. And so it says, here's the instructions, right? Here is what we want you to do. And that's the less important part. What is the super important part is the output type. So here we're saying, we're basically dictating how do we want the AI to respond. We're saying, hey, I want a buff payload. And it's not just a string. It's actually a collection of strings. And then here we have a list of stat changes as well too. So 3 strings, an int for how long the buff lasts, but then also a list of stat changes, which is kind of like a nested object, and it's a list of nested objects. So here we actually get, many or potentially many stat changes that belong to the stat change array. And so it kind of becomes a really cool way to structure data. And so we're using AI now, not just get string responses, but pretty this is a super complex response, but it's more complex than we had even a year ago. So, and what's cool about this is that essentially, you dictate what you want to the agent, and then we're like, hey, shoehorn it into this data structure. And so, and it does that. It does a really killer job of that. So here we got it's been really consistent. I actually haven't had any issues. And so it does enforce that structure really nicely and in a way that other programmers can basically, count on the data structure that's coming back from the AI to follow a certain. And of course, you put layers in between that. So there's a FastAPI layer that, validates the data before it goes back to the front end. But we're getting that from the AI now, which is, I think really cool. And this app was pretty neat because the way it's set up here, it's set up with, queues and all this other stuff. So let's actually go back and write one more buff here. So we'll say a water. And this is like true LLM fashion. So I could start to dictate how I want the image to look and all that stuff. But we'll hit send. So it's not just generating an image. It's actually figuring out the title, the description, and I can feed it all of the information if I want. So it's creating title rush. But you can see here it's generating. And so it's goes through the process and builds up the buff over time. And so we sent the request out, but we're getting kind of these micro pings back, and we're using sockets and notifications essentially broadcast to update this as it goes. And so we got title rush here, and it gives us +5 speed for 180 seconds. But the way this works is that, we enter in the prompt on the React UI and it sends a post. Now it inserts it into the Postgres database right away. And once it gets a successful response back, it sends back a 202. And then we also broadcast the message out. And so there's a broadcast receiver here in the React the React application that knows to go get the buffs whenever it gets that buffs updated. So it's getting the updated list and pulling it down and then re-rendering. So FastAPI then sends those things back, but then it also puts that request into a queue. And then a service worker picks up that. So we're porting this over to the queue. And then a prompt worker, the service worker, comes in and basically dequeues the job. So it's pulling the job into the worker itself. And then it's sending it off to OpenAI to be processed. We get that metadata back. Once we get that metadata back, we get that interstitial broadcast. So first things first, we're going to go ahead and put that into the database. So that way, when the front end goes to pick it up, it's there. Once that comes back, we're going to broadcast back to the front end saying, hey, buffs have been updated. And so that's why we get the title before the image comes in. So it goes and gets that updated buff list in a different status, pulls it back down, re-renders. And then as that's happening, it goes and sends the request for the image off to another service called Retro Diffusion. Super cool little model here, by the way. I'll go ahead and plug this. So they have an API that I think it's about $0.01 an image, basically, but you can go ahead and send that off to get pixel art back. So we go and request the image comes back. We do what we need to do to convert it to a PNG. We store the PNG. Actually, I save it locally right now, but of course you put that into an S3 bucket. So we store that image, reference the URL into the database, and then we go back to the front end and say, hey, we're updated. The front end goes and grabs the list, pulls it back down, and re-renders this time with the image intact. But I'm really excited about, and obviously this is just OpenAI, and so it's not secure the way that most developers would like it to be. Certainly if you were doing something where you needed to, have off a closed LLM system, this would not be the answer. But I'm really hopeful that this is the direction that we're heading with our foundational models and their ability to respond in structured ways rather than just get strings back. And I'm just kind of excited about this whole field in general. So I don't know, kind of it was a neat app to build. I got a couple other apps that I'm going to play with in the same space. And if you're curious about how AI can create endless gaming, I'll be writing updates over here in the Aftercamp blog, along with probably courses on how to do a lot of this stuff. So check out aftercamp.io if you are interested in kind of following along. But like I said, I just thought I'd do a little demo, explain how the demo works, and talk about why I'm excited about structured outputs. All right, thanks everyone.